Hello guys, it's your girl Excellent the Mess Doctor and welcome to my YouTube channel. So today I have another very interesting maths video for you guys and simplify. And one thing that you must make sure that when it comes to simplifying the expression, it consists of what kind of terms or what kind of an expression is it, because now the expression is different. It could be an exponential expression, it could be an expression or it consists of a lot of fractions, like they are different, meaning or when it comes to answering them, you don't answer them the same way. You use different methods depending on what type of an expression it is. Okay, so in this case right now we have fractions. Our fractions get 8x plus 2 over 4 plus 6x plus 7 over 6, then minus 9x minus 11 over 3. So I'm going to simplify this expression here looking at the fractions. What can we do? Okay, every time when you come across fractions that simplify, you must make sure that you look for what we call the LCD. LCD it operates when it comes to the fractions, because LCD it makes it possible for you to add the fractions, because don't forget the fractions cannot be added unless they have the same denominator. So by looking for the LCD, which is the lowest common denominator, you're looking forward for a denominator it can be common for all of the fractions. So let's look at our denominators here. The denominator, I'll highlight them for you. Okay, 4, 6, and 3. These are our denominators, the numbers at the bottom. So by looking for the lowest common denominator, we are looking for the lowest number 4, 6, and 3 can enter into without leaving any remainder. You get the point? So in this case, our LCD is going to be 12. 4 gets into 12, 6 gets into 12, and 3 gets into 12, and none of them leaves a remainder. And it's the lowest number that all of them can enter into without leaving a remainder, right? So that's why we say it's the LCD. Then from here, this is what we're going to do. Let's look at the first fraction here. 8x plus 2, right? Over 4. Since our denominator is 4, we need to make our denominator the same as the LCD. That's the purpose of looking for the LCD, so that we can change the denominators to be the same as the LCD. So if denominator like 4, we need to change 4 to become 12. How? By multiplying it by a number, it will give us 12. So 4 to become 12, you just times it by 3. Okay, this. If you say 4 times 3, you're going to get 12 again. So, okay, 4, you times it by 3. 4 times 3 is 12. Meaning that the numerator, you're going to have to times it by 3 as well. Because if you're going to times the denominator by 3, you cannot leave the numerator the way it is. You must change everything from the top and the bottom. Then we go to the next fraction. The next fraction that we have is 6x plus 7 and over 6. 6, we change it, or even 12 as well, just like we did 4. 6 to become 12, you times it by 1. You just multiply it by 2. 6 times 2 is 12. Then we do the same to the numerator. We times it by 2. Then the last fraction. Okay, the last fraction is minus 9x minus 11. All over 3. 3 we change it to be 12. 3 over 12 is you multiplied by 4. So it's gonna be times 4 and the numerator times 4. Then this is what we're going to do. We're just gonna multiply just like we said. We multiply the numerators by the number in front, and we also times the denominators as well. So 3, this is distribution. We take 3, we times it by 8x, right times 2. So that's how you distribute it. So you're going to say equal to 3 times 8x. 3 times 8 is 24. So 3 times 8x is over 24x. Then 3 times 2 is 6 over... I'm going to put everything under the same denominator. And the denominators, we are seeking to make them look like the LCD. So 4 times 3 is 12. 6 times 2 is 12. 3 times 4 is 12. So that means that the denominator for all the fractions is going to be the same. So I can write all of these numerators, then I put them under the same denominator, which is 12. Because all of them, the denominators are all going to be 12. So more we have 24x plus 6. Then we say plus, we go to the next one, 2 times 6x. 2 times 6 is 12, so it's going to be 12x. Then 2 times 7 is 14. And like that. Then we say minus. When you see a minus sign, run to put brackets. Otherwise, you're going to have a challenge, especially if you now determine. So you see the point. Moki, when it's plus like this, even if I don't put the brackets, it won't make a difference. Because positive sign, it won't change any of the signs that are here. But negative, when you have a negative in front of a fraction, and you're gonna need to multiply it by the numerators. So that's why you need to put the brackets. This one, if you times it by the numerators, the signs won't change. So that's why I don't need to put brackets. But for a negative sign, I do. The negative sign, I put the brackets. Then I multiply 4 times 9x. 4 times 9, 9, 18, 27, 36. So it's going to be 36x. Then 4 times negative 11 is going to be negative 44. Again, negative 44 like this. Then all over 12. Right. Okay, then from here we look for like terms again. Okay, before we look for like terms, let's simplify this bracket. I want to remove the brackets so that we can be able to add freely. How do we remove the brackets? Okay, we're just simply going to do like this. Record the negative sign, we multiply it into the brackets. We multiply it by the numerators, just like I said. So you say negative times 36 is going to be negative 36x. And then negative times negative 44 is going to be positive. Do you see that the sign changes? Even 36 is positive actually, but when we times it by the negative sign, it becomes negative 36. So the negative sign is changing the signs of what? Of the numerators that are here. This one it was positive, this one it was negative, but when we times by a negative sign, the signs will change. So let me do this. Negative times 36, it will give us negative 36x, then negative times 4, it will give us positive. Negative times negative 44. Negative times negative 44 is going to be positive because we're having the same sign there that we are multiplying. So it's negative 36 plus 44, right? Okay, then now we can look for like terms. The like terms, we look at the like terms in terms of the variable. They must have a common variable. The variables, they must also have a common exponent. If they don't have variables, it means that the constant, you still pair them. So we have 24x here, and the like term of 24x is 12x because it has x, as well as negative 36x because it has x. And the x, they have a common exponent of 1 because they didn't write an exponent here, meaning it's 1, 1, 1. So they have the same exponent. The exponents, they have the same, they have the same variables, and the variables have the same exponents. So which means we can add them. So we say 24x plus 12x. 24 plus 12 is 36. So we're going to have 36x. Then 36x minus 36x is 0. So what happens is that they cancel each other. When we add them, they equate to what? To 0. Okay? Then what we are left with is the numbers. We are left with 6, 14, and 44. These ones, key constants, they don't have variables. So you say 6 plus 14 is 20, right? Then 20, if you add 44, you're going to get what? 64. See that? 6 plus 14, 20. 20 plus 44 is going to be 64. So you're going to have equals to 64 over 12. Okay, 64 over 12. How many times does 12 go into 64? Okay, let me do it on the calculator and see. This one, it will just be simplified to 16 over 3. So the answer, if you change it to decimal 4,333, so the answer is 16 over 3 here. Then, yeah, this is the answer. Then, okay, I have another question that I'm going to do with you guys, right? It's also simplified, but we have, our denominators are quite a bit different. This is the one, you see it. x over x minus 1 minus 12 over x squared minus 1 minus 6 over x plus 1. So this is the other fraction that we have, but the difference with the fraction that we have now is that the denominators are not constants like the one that we're dealing with, where we can say the LCD of 4, 3, and 6 is what is 12 because all the numbers get into the number. So this time our denominators are a bit different because they have unknown values. X is unknown, so it means that our LCD, we can construct it in a certain way. I'm going to show you how. Okay, this is how we're going to do it. LCD. Okay, before we go to the LCD, I just noticed something here. If you look at what we have here, it's x squared minus 1. This is what we call the difference of two squares. Difference of two squares. How are you able to spot the difference of two squares? X squared, this one is obvious that is a square because it has an exponent of 2. So number one, a square, you can spot it with an exponent of 2, right? Or if it doesn't have an exponent of 2 like 1, how do you know that 1 is a square? Because there is a number that when you multiply by itself 2 times, right, it gives you 1. If you say 1 times 1, it's what? It's 1, meaning 1 is a square because there is this number that when you multiply it by itself, it gives you 1. So that's how you recognize a square. Even 4, for example. 4 is a square because if you take 2 and multiply it by itself, it gives you 4. So that's how you recognize a square. Then we know that it's the difference of two squares because it has two squares as well as a negative sign. If it doesn't have a negative sign, if it's two squares, but the sign is positive, you cannot factorize it. It's not possible. That one we call it the sum of two squares. The sum of two squares, you can't factorize it. Okay? It's only when it's the difference, when it has a negative sign. Okay. Let's factorize it now. I'm going to write equal to, then x over x minus 1 minus 12. Then we factorize it here. The difference of two squares, you factorize it firstly by opening two brackets like this, right? Then you're going to look at the first square. You look for the square root of the first square. Our first square is x squared. What is the square root of x squared? It's x. Why? Because if you say x times x, it gives you what? X squared. Meaning that x is the square root of x squared. So you're going to write the square root of x squared here, x, in one bracket and in the other bracket. So you write x here, so that when you times them, when you say x times x, it takes you back to what? To x squared. Then from here, since we have a negative sign, it means that in the bracket we should have two different signs. Why? Because two different signs, when we multiply them, they're going to take us back to the negative sign. You cannot write the same sign here and expect to get a negative. Because when you multiply a sign that is the same, whether it's negative times negative or positive times positive, the answer will automatically be what? Be positive, because you are multiplying the same sign. So we need to write two different signs so that we can get a negative sign. Understood? Okay, I hope that is very clear. Then from here, we go to 1. 1, we say the square root of 1 is 1, right? Because if you say 1 times 1 is 1. So it's x minus 1. Here we have the difference of x and 1. It's x minus 1. Then here we have the sum. So that's how you factorize it. Sum meaning that you are adding them. Then we go to the last one, is 6 over x plus 1. This one we just have it as it is, just like the first one. Then now we can go to the LCD that we need to look for. Our LCD, when we calculate it, in this case, you just look for what is in the denominator, not in the terms of like, will each of the denominators get into the number. So here we're just going to be looking at what is common, like x minus 1, it's part of the denominator, then x plus 1 as well. So you just look for everything that is part of the denominator, you write it. Because we cannot necessarily say that we are looking for a number that all of them can enter into. Because these ones, they are not like real, they are not values that we know. They are not like numbers that we can say this number is 6 or 7. They have unknown values x. So we don't know the numbers there. So that's why we just write everything that is in the denominator, x minus 1. We only write 1, don't write 2 of them. if it appears twice, just write 1. Then x plus 1, it's also there, then you write it in the LCD. Then from there, okay, I think I'm gonna need to go to the next page. The first fraction is x over x minus 1, right? Okay, let me do this. X over x minus 1. This one is lacking something in the denominator. That is in the denominator. It has x minus 1, but not in the denominator, in the LCD. Remember, our LCD is x minus 1, x plus 1, right? So this one, it only has x minus 1, whilst our LCD has x minus 1 and x plus 1. So what are we going to do? We just times it by what? By the one that it doesn't have, which is x plus 1. Meaning that the denominator of x, we're also going to multiply it by, okay, let me write with a different color to show that we are taking from our LCD there. Okay, x plus 1, then x plus 1. We are adding it from where? From the LCD, because it must be part of the denominator. Then we go to the next fraction. Minus. Okay, the next fraction is the one that we factorized, remember? The one that we in which we factorized the denominator. The denominator that we factorized, we got x minus 1, x plus 1. This one, it has everything that is in the denominator, in the LCD. You see it? So we don't need to put anything extra. Everything from the LCD is here. So it means that it's fine. Then we go to the last one, minus, the last one is 6 over x plus 1, right? This one, it lacks something just like the first one. It has x plus 1, just like the LCD, but it doesn't have x minus 1. So we need to put in the x minus 1 there. So I'm going to times that x minus 1 more, then even on top I times that x minus 1, because it's something that it wasn't there original. We put it there because we want to make a common denominator. Then from here, we're going to say equal to x, we multiply, we substitute, what is that word? Distribute. We distribute just like we were doing with the first one. We take x, we times it by x, and we take x, we times it by 1. X times x, it gives us x squared, then x times 1 is x, right? Some say 1x. 1x, we just say x because the 1, we don't necessarily write it in front of the x, right? Then we're going to put everything over the same LCD. X minus 1, x plus 1, x minus 1, x plus 1. They all have the same denominator now. Then we say minus 12, right? This one, I don't put the brackets because we have only one number there. So I just write the negative sign in 12. If you say negative times 12, it's going to give you negative 12 still, right? Then we say minus. Then this one, I'm going to need to put the brackets so that, okay, let's do it like this. 6 minus x, we distribute again. Then 6 times negative 1. 6 times x, not 6 minus x, sorry, 6 times x. 6 times x is 6x. Then 6 times negative 1 is negative 6. Then we times it with the negative sign in front. So this one, I need to put the negative sign so that I don't accidentally write negative 6x minus 6. You have to remember that 6x and negative 6 are both part of this fraction, so they must both be multiplied by the negative sign, not only one of them. So negative times 6x is going to give us negative 6x, then negative times negative 6 is going to be positive 6. Negative times negative is positive, right? So that's why it's positive 6. So we're going to have negative 6x plus 6x like this. Negative 6x plus 6. Then we look for like terms. Firstly, we have x squared. X squared doesn't have a like term. There's no other x here that has an exponent of 2. You see that? So, okay, I'll say equal to, so I'm going to write the x squared alone. Or should I? Let me just write it under here. X squared, I just write it the way it is. I can't edit with anything. Then we look for other like terms. We have another x here. This one, it has a like term because there's another number that has an x with the same exponent. So that's why I said the x's must have what? Common exponent. This one it's an x, but you can add it with this one or this one because the exponent is 2 and this 2 have an exponent of what? 1. So okay, let's add them. X minus 6x. This x, don't forget that there's a coefficient of 1 in front here. I say that the 1 we don't write it, but you must always know that it's there, right? There's a 1 in front here. So it's like saying plus 1, positive 1, minus 6. What is 1 minus 6? When you have 1 minus 6, the simplest way to calculate this, if maybe you can't use a calculator, you just look at which one is bigger, not in terms of the signs. Ne? Between 1 and 6, we are not looking at their signs. Between 1 and 6, the bigger one is 6. If you're not looking at it in terms of the signs. So you take, since they don't have the same sign, this one is positive, this one is negative, you take this one 6, you minus 1. So then you say 6 minus 1, it will be 5. Then you write 5. You write 5. But the 5 that you're going to be writing here after subtracting 1 from 6, it should take the sign of the bigger number, which is 6. 6 is what? Is negative. So it means that 5 will take negative. Simply like that. So I know that a lot of people are confused by this when they say 1 minus 6 because they are used to 6 taking a bigger number and subtracting a smaller one. So this time is a small one subtracting, like it seems like it's bigger. Actually, negative 6 is smaller than 1. So because in this case you are thinking of 1 and 6 individually without looking at the signs, it becomes like it might confuse you a bit, but you just do it the way that I showed you now. There's going to be negative 5x. You see that? Then after you say negative 12 plus 6, you do the same. You look between 12 and 6 when we are not looking in terms of the signs. Which one is bigger? The bigger one is 12. So you take the 12 because they don't have the same sign. You take the 12, you subtract the 6. 12 minus 6 is 6. So I said you subtract when the signs are not the same. If the signs are the same, don't subtract, you add. Okay? So you say 12 minus 6 is 6. Then you look at the one with the bigger x, the bigger number, and you take the sign of the bigger number. So between 6 and 12, you say 12 is bigger, 12 is a negative, so that our answer is going to be negative 6. Just like that. Then over what? Over x minus 1, x plus 1. Then the last step, you just factorize the trinomial. Trinomial means that it has 3 terms, right? So trinomial, you factorize it like a difference of 2 squares. I mean, in terms of the brackets, you open 2 brackets like when you're factorizing difference of 2 squares. Then you look at x squared. The square root of x squared is x. So you write x here, x here. Then you look at term number 3. It has a negative sign. So you're supposed to have 2 different signs so that when you multiply them, they can take you back to where? To the negative sign. Then you look for the factors of 6, which are 1 times 6, 2 times 3. So the factors of 6 are only 4. 1 and 6, 2 and 3. So which one are we going to put here? Is it 2, 3 or 1, 6? They are in pairs. Okay? You must take the correct number with its pair. That's why I write it as 1 times 6, 2 times 3, so that I can know which one goes with which one. Okay, let's start with, you were just testing, right? Let's start with 2 and 3. I'll write 3 here, I'll write 2 here. You might wonder, why don't I put 2 here and 3 at the back? It's because 3 is bigger than 12. I mean, not 12, sorry. 3 is bigger than 2, right? If 3 is bigger than 2, it should take the sign of the middle number. The middle number is a negative. So 3 is bigger than 12, it takes the sign of the middle number. That's why I put it with the negative sign. So if you say negative 3 plus 2, the answer that you're going to get is negative 1, right? But the coefficient of the middle term is not negative 1. It's negative 5, which means they are wrong. Then you remove them. It means that the correct one, it will be 6 and 1. And you still do the same. You take the bigger one, it takes the sign of the middle term, which is a negative. Then negative 6 plus 1 is going to give you what? Negative 5, which means they are correct. And if you multiply them, negative 6 times positive 1, it will still give you the negative 6 here. So they are convenient for the last term and the coefficient of the middle term as well. Then over what? Over x minus 1, x plus 1. Then we have something that is common here, x plus 1 on top and at the bottom, so they cancel each other. Meaning that our answer, therefore, it will be x minus 6 over x minus 1. Then we are done. This is the final answer. You see that it's very easy. So this is how you deal with the fractions, as long as you can know how to construct your LCD and you know how to make sure that each and every fraction in the expression, it has the denominator that looks like the LCD, then you're gonna be fine. Then you add the numerators, all of them, once the denominators are the same, until you get to your final answer, which is this one. So this is very easy, guys. I hope you really enjoyed the session. And don't forget the first one as well that we did. This one, don't forget that the denominator was a number. We look for the number that all of them can enter into. So they are different in terms of the denominators, but very easy to calculate. So thank you so much, guys, for watching the video. I hope it really helped you so much, right? This is how you simplify fractions. Okay, and that's all for today, guys. If you're looking for more math sessions, right, you wanna increase your knowledge in terms of mathematics, wanna learn more topics and everything in terms of maths, make sure that you contact my number 081-703-1197, and I assure you that your marks will grow so much that you'll be amazed. How did it happen? Like, I have testimonies of students who grew from level 2 to level 7. Imagine, I was also surprised. I even posted the video on TikTok. A student going from level 2 to level 7 in maths. That's a great difference. So if you're interested, make sure that you contact the number that I give you, right? Thank you so much for watching. Don't forget to like and subscribe. Thank you. Bye.